If you have, please raise your hand. And
if I may ask, there was a recent report saying that the Bell's theorem, or the action at a distance idea, could alter our notions or the theories regarding evolution of the universe. Because the action at a distance is the Bell's theorem, which there was a recent report from MIT, USA, saying that they have found a way of checking whether that actually, or what would be the impact on the evolution theories that affects us today. Could you please comment?
I'm sorry, I didn't quite catch the theorem. The which theorem?
Action at a distance.
Oh, actually, yes. Sorry. Well, I can't really help much. I didn't see what the MIT people said, but frequently people come up with different proposals which are quite honourable. And, for example, does the inverse square law really work? And so on. And so it could be one of those examples. But if anybody else knows the answer, maybe Kumar knows.
Not really. There is a link between what you're asking, Bell's theorem and action at a distance.
Yes.
Einstein and Newton started it action at a distance. It's a different context altogether. I don't think we quite get with what I'm explaining.
That's what the report says.
You know what? Every now and then, I'm sure you say honorable scientists.
Yes.
Honorable daily, but all of them they don't necessarily plan to test of that. That's why Einstein still is highly regarded, whatever he said, including something he resumed in the cosmology of the future. You know the mistake he made.
I think we are running short of time, so may I request you to be brief?
Is your view regarding the existence of black holes? Recently, there has been some
The distance of, I'm sorry,
black holes.
yes.
Existence of black holes.
Yeah.
Itself, there is some controversy.
Well, I don't think that, frankly, there may be discussions on, but there's enough evidence to show there is certainly vast, enormous concentrations of matter which have to be called black holes in the sense that they are normally described. And one can even see a black hole in our own galaxy through nearby stars moving very rapidly in a very small volume. It couldn't just be normal matter in a normal, condition. And also in the centers of relating to supernova explosions, one can see remnants which would be black holes, and neutron stars are related, which are very dense regions. It all fits together, and depends on the mass of the original star. So, and furthermore, for example, in quasars, where, like the centers of some galaxies, we have a black hole, but it's not such a big one, so to speak, massive one. But where you go to about 100 million solar masses, optimum for producing a lot of energy from simply gravitational infall. Now, what is this? It's still gravity. The matter is matter. And the difference between the black hole and just the normal matter is that it's in a very small place. So if you had the same amount of mass, 100 billion suns, in a normal sort of collection of stars and stuff, you wouldn't get the extreme gradient of gravitational field that could be converted to energy through simply infall. But if you have very small volume of enormous amount of mass, then you can get close enough to produce a high gradient of gravitation So we haven't got place, but what one could do is, all one could do is to say, we see the effect of it. So if the effect is correct, now the way it's done is to divide, obviously devise a method, and the method is simply Hubble's method. You look at an object at some distance, know how bright it is, and then gauge whether how bright it should be rather, and gauge from the speed whether it follows Hubble's law in a certain sense. Right? It's not he didn't go that far. But, So what one does is to take a standard candle. Now in the case of the more local stuff, you do stars, I said Cepheid variable stars, stuff like that. And actually with satellites now, another one gone up, astrometric satellites go quite far with just parallax with such accuracy that you can. But here you need something much brighter than a normal star because we're looking at like half the age of the universe back. And so the thing to do is have a supernova, special type 1a. You work it out and you seem to get the same, and it can be calibrated to a degree, the same amount of light every time, or predictable amount of light every time, with slight corrections. And the assumption is that the same objects at half the age of the universe as now, if they are, then the universe, they appear to fate. In other words, the universe got bigger. And you can see before that the universe has been slowing. Hubble effect, is the Hubble law is changing, various things tell you slowing down, and then it seems to be, and it's simply from measures like that. Now, if there's enough inaccuracy, then it's not true. But the evidence is that, and people sort of believe it to the extent they got a Nobel Prize, and that's as far as we know. I'm not an expert on that, but I haven't heard the solution yet myself. But of course people are working on it. So whether it's, it calls itself quintessence sometimes, or it's the cosmological constant sometimes. And so things are being tried. And it could be varying, it could be constant. For example,